So big key idea for our centroid. If you have medians from a vertex to a midpoint, cut each of these segments into two parts. The longer part from the vertex to the middle is twice the length of the shorter part, and the shorter part is 1/3 of the total. This is 2/3 of the total length. And altitude, I always think of like flying a plane. If you're in an airplane, your altitude is the height of the triangle. And we're going to do this from any vertex. And our orthocenter is where the altitudes meet, where they intersect. It's our point of concurrency of our altitudes. So for example, if I wanted to find the altitude of this plane, doesn't matter what kind of triangle I draw. Here's the grass on the ground, and let's make a nice pretty blue sky. So here's my airplane. The altitude, the height, is going to be, in red, the distance straight down to the ground. So in any triangle, it's the distance straight down to the opposite side. And where the three altitudes meet, altitudes, that should be altitudes, where they meet, that is called your orthocenter. There's nothing else really fancy about your orthocenter, but we can use our protractors, or we could just eyeball a nice right angle there. What's interesting about our altitudes or our heights is that sometimes we have to extend a triangle in order to make a 90-degree angle. So for example, on this side that I'm highlighting right now in orange, I might have to extend that side of the triangle in order to get a 90-degree angle. So note that this 90 is only possible if I go outside the triangle. And if I were to try to draw the altitude from the other corner, the third corner, I would end up with a similar problem. So that doesn't always happen. Sometimes you have nice triangles where you've got 90-degree angles that are relatively easy to find. And then if I find my 90-degree angles, I can figure out where approximately those three altitudes meet for my orthocenter. I would ask you to try sketching out one acute triangle and then one right triangle as an added challenge. The acute triangle, you can just sketch out your height from each side, find your 90-degree angle from each side approximately. Using a straight edge makes this a lot easier. What's different about a right triangle is that if you try to do a right triangle, you can find the altitude from one part here from the 90-degree angle, but what's interesting about, let's say, corners A and C is if you want to find a right angle or a perpendicular line from A down to the opposite side, the only 90-degree angle is just straight down. There's 90. And we have the same problem with C to B, where the only 90 is right there. So our orthocenter ends up being right at the corner at B, which is kind of strange. But what's very important for you to know, what I really want you to get out of this, is drawing in your 90-degree angles. All right, I'm going to ask you to try, if you would, drawing an obtuse triangle, and we'll see what happens. If I draw an obtuse triangle, I'm going to get kind of a weird result here. If I'm drawing an obtuse triangle, I need to make 90-degree angles. My first 90 is not too bad. I can identify that height. But if I turn my paper to find the other 90s, I have to extend this side out, otherwise I'm not able to find a 90. So I can draw in my height now, but only because I extended that side. So now I've got a 90. And I can continue this down as well. And I would turn my page one more time. Turn my triangle so I can find the 90-degree angle from each corner, and they're going to end up meeting. Let's see. Let me extend this one. If I try to find the altitude from the top angle here, I'm going to have to extend a little bit on this side as well. So let me change the colors here just to make it a little bit easier to see. So we extended the sides a little bit. If I want to make the altitude from that corner, to the opposite side, again, I'm going to run into this issue where I've got to go down to 90. And then if I extend that a little bit more, I get my orthocenter right where those three lines cross. So your obtuse triangles, what you have to do is you have to extend. You have to extend a side of the triangle. Like here, this is only possible to make a 90 if I go straight down. But I have to extend this side of the triangle to get there. All right, I'm going to share a couple more pieces of information in a second video, so stay tuned for part 2.